Hello everyone, I am Professor Amit Bhosle, working as Assistant Professor and Head of the Department in Artificial Intelligence and Data Science Department. Today we will study the breadth-first search algorithm of Artificial Intelligence Lab, which is our experiment number 4. Breadth-first search is also called as the BFS algorithm. The best-first search algorithm is also type of the uninformed search algorithm that we have previously seen the depth-first search, which is also an informed search algorithm. The base first search is also a type of the uninformed search algorithm. Uninformed search algorithm means what? We don't know the value of the next node. That is how much cost will require to reach from node A to next node B. That is an uninformed search algorithm. Uh, as DFS uses the stack to store the visited node, the best first search algorithm uses the queue to store the visited node, and it store the visited node in first out order. That is the node which is stored first is uh, remove the first. That is first in, first out. In the order which is added first, that node is remove the first. And it is a BFS algorithm optimal path. That is, it will give the path which is a 100% optimal, that is which is 100% shortest. That is our optimal path. Now we will see how BFS algorithm works. Starting from the initial node, we will define the one queue. And starting from that queue, we store the starting node into that queue. Uh, at each time, we will check the current node is goal node or not. If current node is not a goal node, if current node is a not goal node, then we will repeat the process, and we will check the each child of the current node. And then current node is inserted into the queue. If goal node is not found, if goal node is found, we will stop our searching. Now, how the BFS algorithm works? That is how BFS algorithm traverses the tree. Starting from node A, the search algorithm will visit the node B, then it will visit at the same rate, that is, it will visit the node C. After that, node C, it will visit the node D, then node E, then node F. We can see that the tree traversal order: A to B, B to C, C to D, D to E, and E to F. That is our best first search algorithm. Now we will implement this best first search algorithm. We will take here one graph set, graph dictionary, which will store the all nodes, that is a tree. Starting from node A, the node the node A has their child node, node B and node C. Then we will add the next node, which is node B, and child of that node B is node D and node E, node D and node E. Then we will add the node C, child of that node C is node F. Then node D. There is no any child for node D. That's why we'll write here empty square bracket. Next node is a node E, and child of the node E is node F. And last node is a node F, which is also empty. Now we will take the list is empty, to store the node. Here we also take the variable q. Now next is part is to define the function name is BFS. Here start is a starting node, then we will do the one loop q, q node equal to q dot pop print node. It will print the node. Using for loop, we will traverse the neighbor of each node. and we check here if neighbor is not in visited, then append this node into the list of visited. Now we will run this program. Is indentation error. This easily. Here we can see the output of our program: A to B, B to C, C to D, D to E, E to F. That is a BFS search algorithm. Thank you.